This is the modified Aufbau diagram. It's similar to the Aufbau diagram that we know, that we usually use in school, but I modify this a bit. The first difference is that I flatten out the subshells there, so we don't have to read diagonally from top right to bottom left. We can simply just read horizontally. So later when we find out, then we just read as per normal from left to right. Another thing I modify is below each subshell, I put the cumulative number of electrons. For example, if you fill up the electrons until 2p6, means total you have 10 electrons. If you end at 5p6, you're going to have 54 electrons, and so on. So it will be faster if you use this modified Aufbau diagram. If you like, you can make your own, and you can count the cumulative number of electron on your own, or you can download mine. Yeah, this is the QR code. If you scan this QR code, it will open up the Aufbau diagram on my Miro file. Then you can copy and paste it to your application, maybe WhatsApp or Facebook or something. Yeah. Yeah. In this video, we are going to do an example of electronic configuration of Fe and Fe2 plus and Fe3 plus. Let's say the question in the test asks you to find the electronic configuration of these two ions. The first thing that you must do, very simple, look up at the periodic table. And from there you can get 26 electrons. So you must distribute that 26 electron, and don't forget it's only the atom, it's not the ion yet. Yeah. Okay. So 26. Then we use this my modified Aufbau diagram. 26 is between 20 and 30. We try to find here. 26 is somewhere between 20 and 30. That means you have a full 4s and partially full 3d. So you're going to have 1s, 2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d something. And what you do, you must remove the rest. So this is it. Yeah. So we just write the electronic configuration until 3D. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 6 I think, and we remove this one. Yeah. And this is the thing here. Because the number of electron is 26, the 3D subshell has only 6, it's not 10. Yeah, 10 is if it is full. Now this is not full, this is partially full. So you have only 6 electrons on Fe. We rewrite that, put it on all in one line. Fe is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. That's how you write down the electronic configuration of Fe. But the question asks for Fe2 plus. So we must remove 2. Which one do you think is correct? You remove 2 from 3D, or you remove 2 electron from 4s? Which one is correct? Yeah, and remember this thing, for the transition metals, when you remove electrons from a transition metal atom, you remove from the outer shell, in this case for S, so you remove from there. Yeah. So this one, the correct answer here is the bottom part. Fe2 plus is equals to 1s2, 2s2, 2p6, 3s2, 3p6, and 3d6. You remove the 4s. Yeah, 4s, nothing there. Similarly, Fe3 plus, if the one that you must remove is the 4s. So this is wrong. The correct one is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5. You remove 2 electron from 4s and 1 electron from 3d. So 3d6, 3d 3d6 become 3d5. Yeah. So that's it. Hope you can understand this one, and see you in the next video. We can do another complicated electronic configuration. See you.